In this video, I'm going to work through a couple problems on the Pythagorean theorem and then one problem on the converse of the Pythagorean theorem from page 412 and 413 in your volume 2 textbook. If you go to page 415, I'm going to work through numbers 1 and 2 and then also number 5. So number 1 and 2, the directions say write an equation you could use to find the length of the missing side of each right triangle, then find the missing length, round to the nearest tenth if necessary. So I started by just simply writing down the Pythagorean theorem. So they labeled C for you, but usually that won't be labeled for you. So reminder that C is always the side opposite the right angle in a right triangle. Okay, and that is, so C is what we don't know in this problem. Okay, and A and B, it does not matter if you make 5A or B, and then 12 will be the other one, because you can see all you're going to end up doing is squaring each of them and adding them up. So it does not matter which one you make A and which one you make B. And then you're just going to square 5 squared is 25, 12 squared is 144. And then next you can just keep working through 25 plus 144 would be 169 equals C squared. And then the last step you will see, no matter how these problems are set up, is that you need to get just the variable by itself. So this is not finished yet. We still have C squared equals 169. So to get rid of the squaring, to undo the squaring, you can take the square root of it and they cancel each other out. Then whatever you do to one side, you have to do it to the other. So the square root of 169 is 13. So the answer is 13 inches. I was using my phone for a calculator a few minutes ago, and I think I mentioned to several of my students about how if you turn your phone sideways, you get to see a calculator with many, many more functions on it. And I noticed that when I was looking for the square root button, our calculators at school it doesn't look like this, but the square root button, if you're using a cell phone, and again, turning the calculator, turning your phone sideways so that the calculator shows a lot more functions. This is what this square root symbol looks like. This is actually the cube root symbol. At the beginning of the year, we talked a lot about cube roots, so that's the button you would push for that. And like to find if you're using a cell phone for a calculator, you'd have to, for the square root of 169, you'd actually have to type in 169 and then go push this button, and then it'll take the square root of it for you. Okay. All right, number 2, I have a lot of it set up for you already. The side opposite the right angle is always C, so in this problem, we actually were told C, and on number 1 we were not. So you can see that I plugged in 60 for C, and then 51, I know they already labeled A, this side A, then this one has to be B. But as I said on number 1, 51 could be A or B. It's going to work out no matter what. Okay, I already squared 51, and then 60 squared. So you can see this one's going to have to be solved a little differently. On number 1, we could just add up these two numbers. But you can see here, these two are not going to be added up. We have to start solving for A. So to start solving for A and getting A alone, we're going to have to take away 2,601 from both sides. Okay. And that will make 999. Then again, take the square root to undo squaring and to get a alone. Again, the square root of 999. Your calculator will tell you it's 31.60, and then there's some more numbers too that come afterwards. So as I read the directions, I told you that the answer needed to be rounded to the nearest tenth. So the 0 tells you that we are going to keep the 6 a 6. So it'd be 31 6/10 yards. And then lastly, number 5. The directions for 4 and 5 say, determine whether each triangle with sides of given lengths is a right triangle. So this is about the converse to the Pythagorean Theorem. This is back on page 413. So it's saying if a squared plus b squared does equal c squared, then the triangle is a right triangle. So we just need to go see if a squared plus b squared does equal c squared to see if that is a right triangle or not. So they already have these for you nicely in numerical order. So you can see that this is the biggest side. This is the longest side, which is always C. Okay, A and B are the legs. They're always the shorter side. And the hypotenuse, C, is always the longest side. So I had to go put in 125 for C, and then 30 and 122 could be A or B. Okay, and then you can go ahead and use your calculator and see if this side, if a squared plus b squared, is equal to c squared. If it is, if this is true, then it's a right triangle. If this is not true, if this side does not equal this side, then it would not be a right triangle. Okay? So it says justify your answer. That just means make sure, you don't just say yes or no. You have to give proof, and this is going to be the proof, and I'm going to let you work that out from there. Okay, good luck. I hope Pythagorean Theorem is going well. Keep working hard. Bye.